Hello ladies and gentlemen, my name is Mr. Dotson-Kelly, an Algebra 2 teacher from East Hartford High School. Today I'm going to show you guys how to simplify rational functions using both GCF and factoring quadratics in one rational function. So here's the problem for you. We are first of all going to give the prompt, which is simplify. And the rational function we are going to simplify is 2p plus 6 divided by p squared plus p minus 6. In a previous video, I gave you a list of steps. If you have not watched that video, I would recommend going back to that video, pausing it at the end, and writing down those 3 steps. Step number 1 is to factor both the numerator and denominator, starting with factoring the GCF if possible, and factoring quadratics also. So looking at this problem, we have 2p plus 6 and p squared plus p minus 6, and each of these is going to be factored differently. My numerator here is 2p plus 6, and I recognize that this will have a GCF, mainly because both terms are even numbers, and at least even numbers have 2 in common. But let's see if there's anything else in common to find that GCF. To find that GCF, I want to list each term separately, write them in their prime factorization form. So we have 2p can be rewritten as 2 times p. Nothing much changes except I'm just adding the dot in between to list it as 2 separate things being multiplied together. I'm going to do the same thing with 6. 6 can be written as 2 times 3. And that is helpful because now I can see that both p and 6 indeed have 2 in common. And 2 is the only thing that they have in common. It's the only factor that we can pull out. So on my next line of my steps, I'm going to have 2 times whatever I have left over. So what do I have left over? I have a p left over from 2p because I've already pulled 2 out. I'm going to highlight it so that you can see the difference. So that 2 has already been pulled out. I'm left with p inside the parentheses. Okay. I'm going to do the same thing with 6. 6, I am pulling 2 out. And what am I left with? I'm left with 3 inside the parentheses. So plus 3. And that is the factoring of my numerator. I now need to factor my denominator. My denominator is a quadratic. It's a trinomial with the highest power being 2. So we have a quadratic trinomial, and we've learned in past how to factor this trinomial. When we factor this trinomial, we want to look at it and think to ourselves, what multiplies to the last term but adds to the middle term? And you're looking at this and saying, hey, there's no middle term there. But there's always a middle term, even if we don't see it written there. If there's a variable and there's no coefficient written, so it's invisible, but it's implied to be a 1. So in order to figure this out, I am going to look at the factors of -6. And so by making a list of the factors, I should be able to find 2 factors that will add to 1. So making my list, I'm going to start with the easy one, which is 1 times -6. And I'm just going to start moving through the numbers. 2 times -3, 3 times -2, and last but not least, 6 times -1. And so now I'm going to take these numbers and I'm going to add them together. I want to find their sum. What do I want them to add to? I want them to add to that invisible 1 from here. So what will that be? 1 plus -6 is -5, so that doesn't work. 2 plus -3 equals -1, so that doesn't work. 3 plus -2 equals 1, that does work. That's exactly what I'm looking for, but just to verify that the last term is not correct either. 6 plus -1 is 5, and again, that doesn't work. So the only one that works is 3 and -2. What that means is that 3 and -2 are my factors, allowing me to rewrite my quadratic as 2 linear binomials. So those 2 linear binomials are going to be p plus 3, and p minus 2, p minus 2. The plus 3 came here, and my -2 came from here. So that's step 1. Step 1 is to factor my numerator and my denominator, which I have now done. I did 2 different steps. One was GCF for my numerator, one was factoring the quadratic for my denominator. There are times when you will have to do both in one location, but not always. So that is step 1. According to my previous video, In step 2, we need to determine what input value will make my denominator equal to 0. So step 2 is determining what makes my denominator, p plus 3 times p minus 2, what makes my factored form equal to 0. And we want to find out this information because we are not allowed to divide by 0. It is illegal. It is something that we are mathematically unable to do. So what we need to do is we need to find the values that will make this 0. The way we determine to find this information is by using something called the zero product property. The zero product property states that if you have two things that multiply to 0, that's the ZPP. The zero product property states that if I have two or more things being multiplied together equaling 0, one of those two things will then be 0. So either p plus 3 will equal 0 or p minus 2 will equal 0. And now we just need to solve these two individual equations to determine what will make this 0. So I'm going to subtract 3 from both sides over here. The reason we subtract, as a refresher from previous years, is we want to add these two numbers to 0. So we end up with p plus 0 equals negative 3, but p plus 0 is just p. Similarly, we want to add 2 to both sides here. Again, why do we do that? So that we can add to 0. And so we end up with p plus 0 is equal to 2. But again, p plus 0 is just p, and that will equal 2. So the value of p equals 3 and the value of p equals 2 will make my denominator equal to 0. But this is something that we cannot have. What that means is that instead of writing it as p equals negative 3 and p equals 2, what I would write is it's undefined at these locations, undefined at p equals negative 3 and p equals 2. So we don't want that. We want p not equal to negative 3 and p not equal to 2. So this is the important information we need for the very last step. Okay, this is important. Step 3 is to simplify the 2 times p plus 3 divided by p plus 3 times p minus 2. And the reason we wanted it factored, we want to look for the factors that are the exact same in both the numerator and the denominator. So the only factor that is the exact same is p plus 3 and p plus 3. The nice thing about that is it doesn't matter what p is equal to. P plus 3 will always equal p plus 3. It's the exact same number no matter what. If p was 5, this would be 8 divided by 8. If p was negative 7, this would be negative 4 divided by negative 4. So it does not matter what p is. So when I have this right here, I am now going to divide and these become 1. And what do we have left over? We have 2 and p minus 2 as our leftover because these two technically divided out to 1, or what some teachers might say, cancel each other out. So my final answer is 2 divided by p minus 2 with the exception and the undefined locations of p cannot equal negative 3 and p cannot equal 2. And this right here is the final answer. I hope that you found this video helpful in learning how to solve and simplify rational functions. See you next time.